So for our first example, we're dividing by x minus 5, which is our divisor. So that goes on the outside, and you would set this up like any other long division problem. X minus 5 going into 3x squared minus 14x minus 5. So our first step would be to find out which number goes into 3x squared, which would be 3x, which is now in our quotient. So we know that 3x times x is 3x squared. And now that we have 3x here, we can do 3x times negative 5, which is negative 15x. Our next step would be to solve this. So we would subtract this to cancel this out, and we would change this sign to a positive, leaving us with x minus 5, which is the same as our divisor, which means it goes in evenly. So this becomes just a plus 1. So our final answer is 3x plus 1.
Here is example problem number 2, and it's 4x squared plus 5x minus 4 divided by x squared minus 3x minus 2. And the way to set this up would just be like our other problem, which would be x squared minus our 3x minus 2. And then we have 4x squared plus 5x minus 4. And so we have to figure out what we'll multiply to this to get 4x squared, and so just be 4. And we put that right above here. So 4 times x squared gives us 4x squared. 4 times negative 3x is negative 12x. And 4 times negative 2 is negative 8. And then you would do the math here to get our remainder. So we cross these out, and the next thing you have to do is change your signs. So it'd be plus 12x and plus 8. So 5 plus 12 gives us 17x, and then negative 4 plus 8 gives us plus 4. So here is our answer, but we have to put it in the final answer form. So here we have our quotient, right? So it's 4 plus, and here we have a remainder. So you put the remainder over the divisor. So it'd be 17x plus 4 over our divisor, which is x squared minus 3x minus 2. And this would be our final answer to this problem. So here's a good method to check your answer. So here we have our main answer here. So we have 4 plus our remainder and then divisor. So you would multiply the quotient by the divisor here. So it'd just be 4 multiplied to the x squared minus 3x minus 2. And then you'd FOIL out. So it'd be 4x squared minus 12x minus 8. And we can't forget about a remainder, so we'd add that to the very end. 17x plus our 4. And then after foiling this all out, and our final answer would be 4x squared plus 5x minus 4, which is just like our previous answer. So that's when you know you did it right.
A shortcut we can use for dividing polynomials by binomials is called synthetic division in the form of x minus k. So since x minus 2 is our divisor, our k value is 2, which can be written in the left side of the vertical bar. And then we would write the coefficients of the dividend in order of descending exponents. So we have 4, which is our leading coefficient, negative 13, and negative 5. So we would start by bringing down our leading coefficient, which is 4, and multiplying it by our k value. So here we would have 8. And so we would add negative 13 plus 8, which is negative 5. Negative 5 times 2, negative 10. So after repeating this process, the first 3 numbers of the bottom row are the coefficients of the quotient, and the last number is the remainder. So our final answer can be written as 4x minus 5 minus 5 over x minus 2.
And here's our example number 2. So it's x cubed minus 4x plus 6 divided by x plus 3. And so we want it in the same form as x minus k, so we do the opposite of 3, which would be negative 3. And you set it up just like the other problem, and you start with your leading coefficient, which is 1x cubed, so you put 1. And we notice that there isn't an x squared, so we have to put a 0 in as a placeholder. So 0 there. Then we have our negative 4, and then our 6. And then you bring down your leading coefficient here, which is 1. Negative 3 times 1 gives us negative 3. And then that would be negative 3, like if you add them. Negative 3 multiplied by negative 3 gives us negative 9. And then negative 4 plus 9, is 5. Negative 3 multiplied by 5 gives us negative 15. 6 plus negative 15 gives us negative 9. And here is our remainder. And these are our leading coefficients for the quotient. So our final answer would be x squared, 1x squared, minus 3x plus 5. And we can't forget about our remainder. So it's negative 9. And then you put it over the divisor here, and it'd be x is 3. There we go. That's our answer. Yep.
The remainder theorem states that if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. The remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. To evaluate f of x when x equals k, divide f of x by x minus k. The remainder will be f of k, as shown here.
So if you want to use the remainder theorem, you can evaluate it by using the synthetic division. So you put 5 here, just like you set up any other synthetic division problem. And then your leading coefficients to be 4, negative 10, and negative 21. You bring down your leading coefficient here, so it's 4. 5 times 4 equals 20. Negative 10 plus 20 gives us 10. 10 times 5 is 50. Negative 21 plus 50 gives us 29. And all you need to know is what your remainder is. And your remainder here is 29.
So we know our remainder is 29, but we can check our answer by substituting our x value into the original function. So 4 times 5 squared minus 10 times 5 minus 21. So 4 times 5 squared equals 100. Minus 50 minus 21, which is equal to our remainder, 29. So we know this answer is correct.